Okay, class, let's begin. So today we're going to look at perfect squares and perfect cubes. So we're going to review kind of our ideas from grade 8 and quickly move on. So let's talk about squares. And when we talk about squares and roots and radicals, we often refer to area of squares. So the area of a square is the side length squared. So we can abbreviate that with the letter S. Okay, so that's the letter, and it's squared. So if we substitute in a number, for example, 7, we would get 7 squared, and our total area then is 49. When we are working backwards, we are doing something very similar. So if the area equals 49, then we can substitute that into our formula for the area of a square. And so A gets replaced by 49. So 49 equals S squared, and then we are squaring rooting. So the opposite of squaring is square rooting, and we keep it equal by doing that to both sides. What do we get? We get the side length equals root 49. So when we are trying to actually do this in our head, really what we're doing is we're saying what two numbers multiply together to equal 49. And in your head, you already know that's 7 times 7. So we can say the side length equals simply 7. So what we're looking to do is split this number when we're square rooting into two equal numbers that multiply by itself. And then the answer is, to square root 7 times 7, a single value 7. So it's like we're looking for pairs of numbers, and we're going to take out a single value. Okay? And that's kind of what we're looking for today. Now when we do this today, we're going to start off very simple, and sometimes we can guess right to our numbers and figure out what they are. Other times we're going to use prime factorization, to what we worked on yesterday, to help us figure out what the value is. And of course, when we go further into simplifying, we'll definitely need to be doing something like that by looking at our prime factors. Okay, so if you see here, this is a perfect square. If we work backwards with 64, okay, that would be the area. So we'd substitute in area equals S squared. And so then 64 equals S squared. And square root both sides. Boom, boom. We get square root 64 equals a side length. And so what we're asking here is, this symbol is saying what two numbers that are the same multiply by themselves to give you 64. And your answer is 8 and 8. And you know that because you probably have it memorized. So what does this function mean? It means the answer is 8. It's the number that's multiplying by itself to get 64. Now, volume is the same thing, except for volume, we use the formula of a cube, which is side length cubed, which is S cubed. Remember, this is the letters, not the number 5. Okay, I know my S's look like 5s and vice versa, and that's why I hate doing area. Okay, whoops, it's a letter. So, volume equals S cubed, volume equals 5 cubed, volume equals 125. If we're working backwards, what would we be doing? Well, we would be cube rooting. So the opposite of cubing is cube rooting. So we would take this number and substitute into our formula of V equals S cubed. So we get 125 equals S cubed. And the opposite then is cube rooting. So cube rooting is you have 3 as the index. It goes inside the check mark, right in that location. And of course, you'd have to do that to both sides. Okay, so you cube root the left side. I'm just going to give myself some more space. And to undo the cube on the right side, you'd have to cube root. And so you would get simply S equals cube root 125. And what it's asking you now that the index is a 3 is what three numbers multiply by itself to equal 125. And so sometimes you're guessing and checking, other times you know the answer. Today we're going to focus on how to get that answer when you have some harder numbers. And so 5 is your answer for cube root of 125. Okay, notice how you have here 2 digits inside the cube root and it equals a single digit. Just like here, so I said cube root, I mean square root. Inside this cube root, you have 3 digits and you take out a single value because the index matters. Now my question is, here's the word index. Your index is this number right here. Index of 2. When we don't write it, it's an index of 2. But for a cube root, what's your index? Your index will be 3. So index of 3. So for an index of 2, you're looking for 2 numbers. Index of 3, you're looking for 3 of the same number. And for index of 2, it's 2 of the same number as well. Okay, so keeping that idea, if you have 400, sometimes it's easy for 400 to rewrite it as the 2 numbers that multiply together. And so you then can see the answer is simply 20. But what if you didn't know that? What if you had no idea that was 20? Well, other than guessing and checking, what you could do is prime factorization to figure it out. So for example, square root 400, we're going to rewrite that into the prime factors. So let's use our factor ladder division. Divide by 2. We're going to divide by our prime numbers. And it's going to take a little bit, but because these are all even numbers, I know it's easy to divide by 2 until we get to 25, because now it's no longer even. But 5 and 5, there we go. So for 400, we have quite a few factors. We would break 400 down into its prime factors, which would be 2 times 2 times 2 times 2 times 5 times 5. Make sure your roof right here covers everything inside the radical. Okay, so now what we're looking for is pairs of numbers. Here is a single value of 2. So, sorry, a pair of 2s, so we can take out a single value of 2. Here's another pair, so we can take out a single value. Now on the inside it's multiplication, so when we take them out, it's also multiplication. There's a pair of 5s, so we can take out a single value of 5. So now we can say square root 400 equals 2 times 2 times 5, which equals what? 20. Okay, so we can use our prime factorization to find our answer for the harder ones. And we use a skill to simplify some questions which aren't perfect squares, and that's coming up in a couple classes. So, number 2, we know what the square root of 64 is, okay? But let's break that apart into smaller numbers. So let's just go 64, do our factor ladder divisions. Go ahead, do it. And so that's what we get. So the square root of 64 equals the square root. Now you'll see here I write the 2, but you don't really need to write the 2. Okay, it's just hidden. So it's kind of like the 1 exponent. All right. And we have 6 of these. 1, 2, 3, 4, 5, 6. And notice that the roof covers all of them. That's really important. The roof covers every single 2 on the inside. Now we're looking for squares, so we're looking for groups or clusters of 2. We can take out a single value. We can take out a single value. We can take out a single value. It's multiplying on the inside, so it's multiplying on the outside. What's 2 times 2 times 2? Well, it's 8. So we can say root 64 equals 8 by using our prime factorization. Now we have the exact same number, but our index is 3. So we're not looking for groups of 2. What we're looking for is groups or clusters of 3 same numbers. Okay. So what we're looking to figure out is blank, 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 groups of 3. Now we already know we can rewrite this because from over here, we can use these numbers right over there, no problem. So that's what we're going to do. There's 6 of them. So we're going to write 2 times 2 times 2 times 2 times 2 times 2. Got to make sure my roof covers everything. So now we're looking for groups or clusters of 3. There's 3, we can take out a single value. There's 3, we can take out a single value. So we can say that cube root 64 equals 2 times 2, which equals 4. So that's our answer, 4. All right, so let's go further on. Now we have 6. So if we're taking out the 6th root, our index is 6. Root 64, 64 is 2 times 2 times 2 for 4, 5, 6 of them. So we're looking for groups of 6, and we can take out a single value of 2. So we can say the 6th root of 64 equals 2. Done. That's all there is. Let's practice a couple more. Try 5, try 6. 5, we know what it is, but let's see if we can get that. So start by doing your factor ladder. Go. Do your factor ladder. Come on, let's go. Quit staring. Math's not a spectator sport. Do the question. Divide by 2, and we get 72. Divide by 2, 36. Divide by 2, 18. Divide by 2, 9. And then we get 3 and 3. So we can say square root 144 equals the square root of 2 times 2 times 2 times 2 times 3 times 3. And we're looking for groups of what? Groups of 2, or 2 of the same number. So we can take out single value for each of these groups of, oops, that's a 3. And they would multiply. So we can say square root 144 equals 2 times 2 times 3. So that equals 4 times 3, which is 12. Okay. Sorry, I was just distracted by a weird noise. It's just my dog snoring. What a dog. Okay, 1296. So let's do our prime factorization for this one. This one's going to be a little bit, so we're going to start up top because it's a large number. It's even, so I can always divide by 2. Now I'm going to use my calculator because I'm a little shaky at this. I'm not going to get it to do the work, but I'll just divide by 2, 648. That seems like a large number. Divide by 2 again, 324. Divide by 2 again. Oosh. 162. Divide by 2 again, 81. Ooh, I can't divide by 2, but 8 plus 1 equals 9, and this I can divide by 3, so I can divide this one by 3, since I can divide 8 plus 9 by 3. Divide by 3, I get 27, that's one I know. Divide by 3, I get 9, 3, and 3. So I can rewrite this as square root 2 times 2 times 2, 1, 2, 3, 4, and 4 of these guys. 1, whoops, that's a 3. 2, oh man, 3, 4. And so looking for groups of 2, 2. Good, there's a group. So 2 times 2 times 2 times 3, and this is a 3, shame on me. And so that we can now say square root 1296 equals that, which is 4 times 9, which is 36. So it's big and complicated, but when you do small divisions with small numbers, maybe get a calculator help, I can get this answer without a calculator. All right, not bad. Okay, so now we're going to play around with the words. We can write numbers as roots. Okay, so roots are the small number, the side lengths of the squares. So we're going to mess around with the definition. We want to write 6 as a perfect square. So if we go 6 equals 6 squared, that would be saying 6 equals 36. It doesn't. So what we can do, though, to make this true, how would we make this true? How? Well, simply canceling out the square. So we can write it as a perfect square if we square root. So we can go 6 times 6, or we can say 6 equals 36 there. But probably for us, we're just going to leave it in the very first, 6 times 6. Playing around with the words, what about 4 is a perfect cube? So 4 equals what cubed? So 4 times 4 times 4. How do we cancel that out so it equals 4? Well, we would cube root it. And so now we have 4 as a perfect cube because we're using the cube root to cancel it out. And that equals 4. What about 6 with an index of 5? So here, what do we have to do inside the radical if the index is 5? So we get the value of 6. Okay, so we're wanting it to equal that number. So we'd simply have to have how many? 5 of them. Okay, so just playing on words a little bit. So the left side equals the right side. They have the exact same value. Okay. Negatives. Don't do that to me. All right, so watch the negatives. Here we have a cube root. So what it's asking you is what 3 numbers that are identical multiply to negative 8. So you can start with negative 1. And that equals negative 1. And what about negative 2? And we're lucky because it equals negative 8. Now, what we're saying and what we've got to be careful of is that we have an odd number of negative signs. And that's important to see. Okay, in order to get a negative, you have to have an odd number. So this equals negative 2. But what about this one? What 2 numbers are identical multiply to negative 4? Well, in order to multiply to negative 4, guess what? You would have to have 1 positive and 1 negative. But these here are different. One's positive, one's negative. So guess what? The square root of negative 4 does not exist. Okay, so D&E is a new answer for you. It stands for does not exist. Or you can also use this symbol. The square root of negative 4 equals null set. All right. This is called null set symbol. which basically means no answer, right? There's no two numbers in the world that multiply to a negative. And so therefore, your answer must express that you know that. All right, D and E or null set. All right, so a few more to practice. Try these with doing prime factorization. All right, go for it. You try them first, and then I'll do them up here. So try the first one. 121. Yeah, guess what? 11 and 11. And so you would go square root 11 times 11 equals simply 11. 196 is a little more real now, so let's do 196 divided by 2. Go for it. Press pause and do it. Press pause and do it. I'm going to cheat. 98 divided by 2. 49. My dog is snoring. Holy cow. He's so loud. And so root 196 equals square root 2 times 2 times 7 times 7. So that equals what? 2 times 7, which equals 14. All right. So we can take it out. There's a group of 2. You can take it out. Okay, 512. So again, go ahead, do it. Come on, start. Do it. What should you divide by? Well, it's an even number, so you can divide by that. So Mr. Barker's going to cheat with a big long answer like that. I would just grab my triples right here. But that's because I know what I'm doing. All right. And so I can say now, cube root of 512 equals, I don't like doing it there. Let me move this so I don't get in trouble with the Math Teacher Association of British Columbia. This equals 2 times 2 times 2, which equals 8. So 8 is the cube root of 512. Okay, try these ones. 81, again, 8 plus 1 equals 9, and this number is divisible by 3. So that means that this number is divisible by 3. So for 81, 3 is your lucky number. And if you're stuck, you could just try 2, then try 3, then try 5, 7, 9. Remember, your numbers you're trying are the prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, and the ones that are the most common are these ones, okay, the very first 5. 27, 3, 9, 3, 3. So the fourth root of 81 equals simply 3, because there's 4 of them. Okay, so 750, it's a big number. I could divide by 2, but you know what? Let's divide by 5 and see if I can get that number smaller faster. So divide by 5, and I get 150. Okay, divide by 5, and I get 30. Ooh, I like this. Divide by 5, I get 6. And I think I messed something up here. So let's try again. 750 divided by 5 is 150. Divided by 5 equals 30. And divide by 5 equals 6. Really weird, eh? And then I can divide by 2 and 3. Well, guess what? Well, I think if I have cube root 750, that would equal cube root of 5 times 5 times 5 times 6. So the 6 is a weird one. I mean, I could write it as 2 times 3, but I only have that one triple that can come out. So that would be on the outside, and what's left on the inside? 6. So we read that as 5 cube root 6. You're going to see some more of those come up in a couple days. 256. Oh, I already did it up here. Okay, so 256, the fourth root. I can pull my answer from up here somewhere. Oh, it's not there. So I'll just use it from up here because I'm super duper lazy. Right here be 1, 2, 3, 4, 5, 6, 7, 8 twos. Surprise, surprise, Mr. Barker. 1, 2, 3, 4, 5, 6, 7, 8. So group of 4, pull out. Group of 4, pull it out. So I get 2 times 2. So I get this, the fourth root of 256. Dang it. Fourth root of 256 equals 2 times 2, which is 4. So there's your answer. All right. Some good application questions here. A square is an area of that. What's the length of the side and what's the volume? So you got to find the length of the side first before you find the volume, because volume is the side length cubed. That's how volume and area are related. Okay, so from area, you got to find the side length, and then you can find the volume. And if you're going in the other direction, same thing is true. From volume, you find the side length, and then you can find the area. That's really important to know. So the area equals s squared. 324 gets substituted in for A. So showing your work in a methodical manner. Remember, writing math is like writing paragraphs. Every detail counts. So then we square root it. Square root the right side, so we square root the left side and vice versa. So we can say square root 324 equals s. So we simplify the root s squared. And so then we can find 324 divided by 2. We get 1, and sorry, I got a calculator. 162 divided by 2, 81 divided by 3, 27 divided by 3, 9 divided by 3, 3. So we can 324 square root equals 2 times 2, 3 times 3 times 3. Good, looking for that. So 2 times 2, 3 times 3. And so that equals 6 times, or 2 times 9, which is 18. So that's what the side length equals. All right, so 18 equals the side length. And then to find the volume. Okay, so 2 times 3 equals this. Equals 18. So then the volume equals side length cubed. So now we substitute into here, and you would show your work because you know how to show your work and replicate it. And 18 times 18 times 18, you use your exponent buttons. Looks like this one, or a little upside down V. You get 5,832. And our units would be centimeters cubed. Okay. Good. Working backwards here then. Cube has that volume. What's the length of the side? So volume equals s cubed. 1728 equals s cubed. So we substitute in for v, and then we cube root it. So I'm going to show a little bit less work, but I show enough that you know exactly what I did. All right, so then you can, let's use a calculator for this one because it's so big. So cube root, let me just press pause for a sec. Okay, so cube root 1728. For me, I gotta press second function. I use this button. And so 1728, whoops, there's 1728. And I did this again. 1728. Hit that button, and the index is 3. Press equals, and I get 12. So that's the side length. So what's the surface area? Surface area of a cube is s squared. And how many sides are there on a cube or on a dice? There's 6 identical squares. So it'll be 6 times s squared. So 6 squares. So 6 times 12 squared. Surface area equals, doing bed mass, 6 times 144. Surface area equals, come on. Oh, I can't get that. 6 times 144, which equals 864 centimeters cubed. Okay, calculator use. So this one you got to check on your calculator. There's 2 ways to do this on your calculator. Square root 387. If you have an old calculator, so in other words, for me, when I press the button, I get my answer. So I go 387, press the button, I get 19.67. So make sure you try your calculator and you do that. I'll bring up my graphing calculator. Okay, so on my graphing calculator, I will go here. I have to punch square root button first so it appears on screen. So if you have your square root appear on screen, then you have to enter it in this format. So then I will simply press 387. And I can have a closing bracket to close it off. Press equals 19.67. Sometimes the closing brackets make a difference, sometimes they don't, but it's always safe to have it so that you can figure out when it's needed. Now phones are this type of calculator. I call this the old school calculator, okay? So if you have a phone, then you got this type of calculator. So I will enter in the number first, 227, cube root it. So I have to go to my cube root button, then press my index of 3, and you get 6.1. Okay, so you try on your calculator, come up and see me if you need help. For this one here, I go 2765, and then I hit this and my index of 5, and I get 4.879. Okay, this one here is 4 times root 5. So I'm going to get that answer on my calculator first. 5 square root. Now I can use my simple root button and then times it by 4 and get 8.94. Okay, so it is a multiplication. So this would be 6 times cube root of 20. So we got to find this answer first and then multiply. All right. Otherwise, you can get some weird things happening if you're not careful. So it's always best to find that first. I press equals to find that answer. Then I times it by 6. And get 16.28. If you need help with your calculator, come up and see me. Make sure you can do all these examples on your calculator. There we go.